Hello, and welcome to this podcast on air pollution. My name is Will Suter, and I'll be talking today to Pascal Lemberge, an application scientist at Thermo Fisher Scientific specializing in XRF spectroscopy. We discussed the importance of measuring and understanding air pollution in the broader effort to improve air quality around the world, and the part that XRF analysis of air filters has to play. I hope you enjoy it. So, hi Pascal, thanks for joining me today.
Hello.
So to start off with, could you just quickly introduce yourself? Tell us a little bit about your role at Thermo Fisher Scientific.
Okay, so my name is Pascal Lemberge. I work as an XRF Application Specialist with Thermo Fisher Scientific already for more than 10 years now. And I'm primarily responsible for EDXRF. It's one of the X-ray fluorescence instruments that we produce. And I mainly develop the applications. I work together with our sales force and also, of course, help our customers with their applications. That's in a nutshell what I do.
Great. So we're talking about air pollution and air quality today. So air pollution is a global threat to human health, with there's much research suggesting that air pollution is one of the world's leading risk factors for death. So can you give us a brief overview into the causes of air pollution?
Yeah, well, it's an extensive question, I would say, with an even more extensive answer. I think the first question should be what is actually clean air? And then if we talk about clean air, typically we say clean air consists of gases which were formed in a natural way. So if you look at air formed in a natural way, it's 99% nitrogen and oxygen, and perhaps 1% of other components such as argon and carbon dioxide and water vapor, also a bit of helium. So air pollution, typically we say, concerns of all the presence of contaminants in natural air. So pollutants that can be gases, that can be solid particles, that can be aerosols. So everything which is actually present and shouldn't be there. And it comes in many forms, of course. We have typical gases that everybody knows, like sulfur dioxide or carbon monoxide, that are present. It's also about trace metals, toxic metals such as lead or cadmium that are present. So there's really a lot that can be present and a lot can be detected, of course. And if you're talking about origins, well, there's actually also natural origins. I mean, you can have air pollution due to forest fires, for example. You can also have volcanic eruptions that will pollute air. But normally we think of anthropogenic sources. And if I think about anthropogenic sources, it's usually or mainly the combustion of fossil fuels, that especially in industrial areas or densely populated areas are a big factor. And that can be from power generation, but mainly also from transportation and industrial facilities. So that's I would say the main contribution to air pollution. But there's also things like agriculture. There is things like combustion, or let's say forest and wasteland burning. So that also plays a role. So yeah, certainly a very important topic.
Yeah, definitely. So obviously one of the main concerns with air pollution is the health impacts that it can have. And particularly there's evidence that it disproportionately affects children over adults during their development. So could you talk about what some of the main concerns are, what kind of health issues air pollution can cause, and why do we see that difference between how it affects children and adults?
Yeah. Well, in general, I looked up the numbers from the World Health Organization, and they have an estimate that worldwide, because of air pollution in ambient outdoor air, let's say, that air pollution accounts for about 4.2 million deaths on a yearly basis. And that can be strokes, that can be heart diseases, lung cancer, everything together. And also, if you add to that, let's say, indoor pollution, you end up with another 3.8 million deaths a year. And as you say, it's certainly even more riskier, let's say, or has a bigger impact on young children and babies, because they are typically in their early stage of development, and lungs and brains are not fully developed yet. So therefore, health effects and pollution in general is more acute and critical. And in the end, it might lead for children to respiratory conditions such as asthma, or even a reduced brain development or functioning. So yes, it's certainly an important risk factor, even more so for children than adults.
Yeah, certainly. So How is air quality and air pollution thought about and talked about differently between indoor and outdoor areas? So obviously, we're talking about we tend to think of sort of air pollution as being an outdoor thing, but there's been growing concerns recently about things like air quality in work environments that are indoor as well. So could you talk about like maybe how those concerns have developed?
Yeah, exactly. As I already mentioned, the World Health Organization defines outdoor pollution, accounting for several millions of that, but also differentiates that from indoor air quality. So outdoor is typically everything which is related to, as I mentioned, industrial processes, power generation, transportation, which certainly is something which we are very familiar with. But indoor pollution is perhaps more of a third world problem than a first world problem. We're talking here about households that are exposed to smoke from cook stoves or fuels that are typically used in house or in the indoors, let's say, and not outdoors. And this is also a very important factor for those people. So perhaps they are less exposed to what we call industrial pollution or pollution due to a city environment or anything. But then the effects of let's say household cooking based on fossil fuels, simply like wood or something, wood burning, is going to have an important effect there.
Yeah, definitely. That makes sense. So, could you talk about, from Thermo Fisher's point of view, what has made you, as sort of a company, as an organization, in the work that you're doing, made you decide to get involved and to sort of join an effort to help reduce air pollution?
Yeah, certainly. Well, it's in general, I would say it's an important problem that needs to be tackled. But if you look specifically at Thermo Fisher Scientific, our mission, as we noted down, is actually to enable our customers to make the world healthier, cleaner, and safer. And in that respect, air pollution is certainly defines as one of the things that we can tackle to meet that mission. So in that sense, Thermo Fisher can mainly provide the instrumentation, let's say, to monitor the different types of air pollution, and in that sense, hopes to help and to contribute to reducing air pollution in general.
Yeah, certainly. So, from that sort of technical point of view, then, about the sort of chemistry that's going on, what are the current methods that are typically used to analyze samples for measuring air pollution?
A lot is focused down on the type of air pollution that we are dealing with. And an important differentiator between the two is the concentration of the different components in air. So if you think, for example, of the common gases such as again the sulfur dioxide or nitrous oxides and things like that, also soot, for example, they are relatively concentrated in air. So they are usually detected directly in air. For that, we are using dedicated analyzers. Those can be based on electrochemical sensors or based on photoionization detection. Also, UV and infrared are used in those techniques. But typically, you have one instrument or one sensor to detect one type of pollutant, one type of gas. Now, all the other pollutants, and I'm talking there of VOCs, volatile organic components, particulate matter, aerosols, polyaromatic, things like that, they are present at a much lower concentration. So direct analysis or direct sampling is not possible. So usually we go for a sampling over time so that you have enough material that is collected over time to accumulate or to pre-concentrate the different components. And in that sense, once collected, they are usually then brought back into solution or another technique that to release them again from the sampling component that we use. But in the end, they are typically analyzed then with chromatography and sensitive techniques such as ICP-MS. But in the end, also also with XRF, and that is part of the podcast as well, of course.
Yeah, and obviously that's your sort of portfolio and area of expertise. So specifically on EDXRF, then, the sort of instruments that you look after, that you're involved with, how do they play into that, and what kind of pollutions can you measure with EDXRF?
EDXRF is specifically used for the analysis of aerosols, so particulate matter in air. So let's say liquids, small droplets that are suspended in air that typically accumulate also different elements often hazardous elements such as lead and cadmium, antimony, things like that. So they are typically present in aerosols. And to analyze aerosols, what is typically done is to collect them over time on a suitable filter. So typically we are filtering, let's say, a large volume of air over a filter to collect as many aerosols as we can. And then those aerosols are directly analyzed in an XRF instrument. So the XRF instrument can identify the different elements that are present. So it's an elemental analyzer. And at the same time, it can determine how much of every element is present on that filter. And then with that information, together with the amount or the volume that was filtered through the filter, we can calculate back what the actual concentration is of those aerosols, of those different elements in air. And that's how we use XRF.
Great. And so, as part of that suite of analytical techniques that you were talking about, what does XRF add to that you don't get? What does it add to the picture that you don't get from other techniques like chromatography and mass spec and other things?
The advantage of XRF is that you can analyze the filter directly. And with the other techniques, you typically have to dissolve the material that is collected on the filter again before you can analyze them with chromatography or ICP or any other technique. XRF has the advantage that you can actually analyze the filter directly. So it has a very high sensitivity. We have detection limits down to nanograms per square centimeter. So the idea there is that you analyze the filter directly, and more importantly, the analysis is non-destructive. So you don't destroy the filter in the process of analyzing it, which is interesting because and useful also because you can always, let's say, do a second opinion, do an analysis with another technique just to verify, or also track back to earlier analysis and go back to earlier analysis and analyze a sample again if necessary. So that's, let's say, the most important advantage of EDXRF is that it's very little sample preparation and that it's a non-destructive technique.
Great. And you mentioned the sensitivity as well. It's a very highly sensitive technique. So how does that help, particularly with air samples? I imagine, does it kind of improve the throughput if you don't, if you can get decent measurement from a kind of smaller collection volume? Does that help you kind of get through samples quicker, or can you, analyze pollution in where you you don't have time, or you're not able to collect a really large volume? Like, does it enable you to sort of open up tests that you wouldn't be able to do otherwise?
Exactly. It's as said, these particulates, these elements are present at very low concentrations in air. So that's already why we pre-concentrate them and collect them on a filter. It's obvious, of course, that in very polluted areas, you don't have to filter a large volume of air to collect enough material on your filter. But in other areas, the concentrations are much less and larger volumes are collected on the filter. Also, of course, you want to differentiate perhaps throughout the day how the concentration of certain components vary during the course of a day. So it's important then that you can still detect the different components even when you have only smaller volumes to collect, let's say, on a filter. So certainly in that way, sensitivity of the instrument is very important. And in the end, I think it remains also important because we are always looking for lower concentrations. Of course, we find out that certain components already have a health risk at much smaller concentrations than we originally thought of. So having a good sensitivity is certainly important there.
Yeah, I guess in an ideal future, there'll be so little air pollution that you'll need an extremely sensitive instrument to even find any.
Yeah, that would be the ideal world, I guess. Yeah.
So, how does that play into kind of other applications within environmental analysis more broadly as well for XRF? Does that, do those same properties also help with things like water analysis or soil analysis?
Yeah, XRF in general as an elemental analysis technique is used a lot in other applications that are environmentally related. Soil analysis, as you mentioned, is an important one. Also, waste analysis, I think, is an important application of XRF to quickly screen incoming wastes to see whether there are certain elements, hazardous elements present or not, and then afterwards, with that information, one can decide what the next step is of the waste treatment of that specific batch that was received. So, waste analysis is an important one. Soil analysis is there. To some extent, also water analysis, but it's mainly, I would say, soil and waste analysis that are very important applications for XRF. Especially because, again, It's the sample preparation which is important. So if you can limit to a minimum the amount of sample preparation needed for a sample to be analyzed, that's really an advantage. And typically, if you're going to work with other techniques such as ICP or chromatography, you'll always need to bring your sample into solution one way or another. And although those techniques can be very accurate and very precise, also with excellent sensitivities, they typically also require more sample preparation. So on EDXRF, you have that less. On the other hand, you have the detection limits on EDXRF that are perhaps a little bit less good than on these techniques like ICP or chromatography.
Great. So, talking more broadly, again, as we've discussed, this is really quite a large health issue in lots of areas of the world, with causing lots of deaths. So, in terms of the effort to kind of fight air pollution, obviously we've seen over the last couple of years with the COVID-19 pandemic, like what can be done when there's a concerted effort to sort of combat a major health issue. Obviously with the fight against the pandemic, the development of vaccines, which has all happened at sort of record-breaking speed through lots of government help and lots of collaboration between sort of scientific organizations. So do you think that sort of broad scale collaboration and sort of global effort could be applied to air pollution as well? And would that be, do you think that's a sort of worthwhile effort that we should push for to help get safer air for everyone?
I think it certainly plays on different levels. There's certainly also the networking effect that there's a much more exchange of information about air pollution. Many countries these days, larger areas like in the US or like in the European Communion, they have or the community, they have like a larger networks of different stations that will monitor the air pollution over a wider area. So as such, you can get much better information, also an exchange of information there. If we are talking about reducing air pollution in general, there has been in the past already a big effect or a big effort to reduce air pollution simply by treating exhaust from fossil fuel burning in general, all the different processes like energy generation and combustion in cars and transportation in general. I think there is still a lot to be done there as well. If we can move on to a, let's say, production of energy in another way than with fossil fuels, I think we can improve air quality a lot there. We're thinking these days of renewables, but also nuclear, for example, does not produce any pollutants while electricity is being generated. So, and in an urban environment, I expect a lot from a shift to electric cars, for example, where you have much less pollution than with fossil fuel powered cars, even though that the exhaust treatment of fossil fuel based cars has already improved a lot to an extent that the pollution is much less than it was, for example, 20, 30 years ago.
Yeah, definitely. I think there's some other really relevant examples there with things like leaded fuel, which is pretty much phased out in much of the world,
Exactly.
and things like refrigerants as well. With the whole panic around the hole in the ozone layer, which is now fixing itself.
Yeah, exactly.
So these things can be achieved. So, what do you think? Do you think there's efforts that individual sort of companies, organizations can do, or do you think some of this has to be obviously a sort of a top-down regulatory approach as well, where governments have to get together and actually introduce rules around some of these things to actually reduce air pollution? How much of a role do you think that plays versus how important is the sort of monitoring of the situation and analyzing where the air pollution is to understand the scale of the problem as well?
It's understanding the problem is of course an important one, and that's where Thermo Fisher can certainly play its role in the sense that with our analyzing techniques and the treatment of the data, understanding where pollution comes from and how it can be combated is certainly a topic where Thermo Fisher can be very effective. On a general scale, for all companies, I think it is. We see more and more that companies are very conscious of how to reduce their pollution in general. So you see that they have a shift towards making or using renewables or something, or absolutely reducing the total CO2 concentration that they or CO2 that they emit as a company. So they are improving their processes, and that also, of course, is going to help with air pollution in general. So from a top down, from the government, I would say that it's certainly the implementation of norms on concentrations of certain pollutants, and then there is on a company level, there are many efforts possible, of course, to reduce air pollution in general.
So finally, then, just to wrap up, what are the next steps for you? As part of Thermo Fisher, like, what are you going to be doing in this area? Is there any research you're looking at, or sort of areas that you want to move into within this sort of air pollution analysis field?
If I think about EDXRF, we will certainly be looking at further improving the sensitivity of the technique. I think we certain heavy elements, we have good detection limits for those elements, but we see that there is a demand for even more sensitive techniques, or at least to improve the sensitivity of EDXRF, because of course people would like to continue use the technique because it's so convenient. But of course, on the other hand, they also would like to see the sensitivity to be improved even more than it already is. A big I think that's in general true for all our instruments. We of course try to improve the sensitivity in general, but also to make sure that we can do an analysis perhaps in a shorter time, so that results are produced faster. And I think that's another aspect which is at least as important, is to improve user friendliness of our techniques and how to use the analytical techniques to produce the results. So I think we see that more and more people, more labs are involved. We see that more of our instruments are used at different levels to control air pollution. So it's important that the more people are involved with it, the more people are using it, not necessarily with an educated background. That because of the software, because of the user friendliness of the software, that the techniques are easy to use and produce reliable results.
Fantastic. Yeah, that sounds great. Okay. Yeah. Thank you very much for the conversation. That was really interesting.
You're welcome.